Great. Thank you, Nicola. Can you hear me well? I
Yes.
readjusted my microphone. Okay. Well, hello, everyone. Good afternoon. Welcome to our seminar today. This is an introduction, as Nicola mentioned. Again, my name is Kevin McKee. I am a solar ambassador. That means I'm a volunteer with the Illinois Solar Education Association. I've been a volunteer with them and their predecessor for the past 8, 9, 10 years. I'm losing track now. Usually I'm talking about solar power, photovoltaics, getting electric power from the sun. Today we'll be talking solar thermal instead. As a volunteer, I do not make any kind of speaker fees or salary or anything else. I don't get money from the industry. I am strictly a volunteer. I do this because I enjoy helping others understand solar energy and how they can take advantage of it and how it can help us all jointly make the world a better place to live. So I've had, by the way, some training in solar technologies, including solar thermal, as a part of getting certified to be a professional, but I never became a professional. I decided instead that I wanted to enjoy my retirement and talk to good folks like you about solar energy instead as a volunteer. So on with the discussion. The Illinois Solar Education Association is a charitable organization, a 501c3 as it's called. It was established a few years back in 1975, and its mission is to educate and advocate for the wider application of solar and other forms of renewable energy. It's not all about solar, but principally we focus on solar. We have a sister organization that is the Illinois Solar Energy Association. We split off from them last year for legal and or tax purposes, and we're strictly an educational wing now for that organization. We are membership based, and we've got hundreds of individual members and hundreds of businesses associated with each. Every year we host the Illinois Solar Tour as part of the National Solar Tour. Typically, we'd also be doing in-person solar socials at our homes, showing off our homes to folks who are interested, as well as maybe conducting the occasional webinar. These days, during the pandemic environment, we're stuck to doing it entirely virtually as we are today. These are the broad topics we'll be talking about: basic solar energy 101, as well as energy efficiency, which is hugely important when it comes to solar energy. But really, anytime you're building a building or modifying a building, we should be thinking in terms of energy efficiency to save us money and to helps reduce our impact on the environment. And then we'll be talking about solar water heating and solar space heating in that order, as well as subtopics within them. And you'll notice that we'll be moving back and forth between them a little bit in terms of active and passive types of solutions, because there's no one way to do this stuff. So on to the Solar 101. Why would people want to go solar anyway? Well, we can reduce our impact on the environment, we can reduce our carbon emissions, and that improves public health. If we have cleaner air, cleaner water, we all benefit. Solar energy also creates jobs, and that's because every installation of solar energy, whether it's solar thermal or solar electric, is a tailor-made situation wherein you've got to have somebody sit down and design that and install it. There's no such thing as a cookie cutter situation that you can install a simple solution to every house, because every house is different, every consumer's need is different. So it creates lots of jobs that way, kind of like a plumber or an electrical job. They can't either go into a building that has a standard off-the-shelf solution and make it really quick and easy to install. Also, solar can save you money on utility bills. It increases your home value. And why not take advantage of that inexhaustible energy supply we have called the sun and the sky? It's been around billions of years. It's going to be around billions of years more. Now, this map was originally created by the Department of Energy's National Renewable Energy Laboratory to talk about photovoltaics, that is solar power generation, and the potential in the US, but we can use the same map to talk about solar thermal because it's still the same sun. We're just using those sun's rays a little bit differently. Now, this map depicts the average solar energy captured across the US during an average year. This is based on historical averages over many decades, I believe. As you might expect, The southwest U.S. gets the most sunlight over the course of an average year. Places like New Mexico, Arizona, West Texas, California, Nevada. And as you also may suspect, Washington State, Oregon, where Nicola's at these days, and then Alaska receive much less sunlight because of their latitude and because of weather conditions. They are at the far extreme on the bar chart that shows you the range of factors here in the U.S. In the Midwest and Illinois, we're somewhere in the middle of that chart, that legend. Would it surprise you to understand that we in Illinois get about 92% of the sunlight that Miami, Florida gets in an average year? You can see there's a little difference in the map in colors, but it's not a huge difference. Miami being down here about 1900 kilowatt hours per square meter per year, and we're a little closer to 1700. We don't have tropical fruit, we don't have beaches, but we get plenty of sunlight and we can use that sunlight. We look, in fact, an awful lot like Spain. This is a map of Spain for comparison. They're a Mediterranean country. They grow fruit, they grow citrus, grapes, things like that. And they are taking advantage of renewable energy in a big way, as is Germany. Germany's on this map because it looks an awful lot like Alaska, yet Germany has installed so much solar energy infrastructure that on a sunny day they export solar energy across their borders in the forms of electricity. Again, we can do the same with solar or similar things with solar thermal by taking advantage of that wintertime sun. And I maintain if Germany can do such a great job of installing solar and taking advantage of it, I suspect we can too with more solar resources. So there are these multiple ways we've already addressed a little bit. Photovoltaic is not really the topic we're going to be talking about today, that is solar generated electricity. Instead, we're going to be talking about passive solar heating of water or air. Passive solar heating, the way I use it, is talking about heating spaces or water without the use of any kind of motors or pumps or fans. It's entirely reliant on, say, the sun's rays or on convection of fluids or gases like the air. Examples include greenhouses, sunrooms, south-facing windows. I have something I left off and I don't remember what it was. That came after that comma. We'll see some examples of all these in a bit. And then I'll be talking about active solar heating during the briefing as well. Active solar heating relies on pumps and fans and motors to move either air or fluids around so that we can maintain a higher temperature in a storage tank, a storage mass, or within our living space. So those are terms we'll be using throughout this presentation. Now, I mentioned energy efficiency earlier as being critical. Here we'll take a short digression to talk about that energy efficiency. It matters because the sun is sort of a weak resource, and we want to use it to the greatest advantage by spreading it out over the course of a day, even though it only comes in for a few hours of a day. We can do that by insulating beyond code requirements. These days, most codes require a minimum of 4 inches of wall with, say, 3.5 inches of fiberglass equivalent insulation. So it's like R12 or 15 by 16 by the time you add the cladding on the inside and the outside. But really for thermally efficient building envelope these days, you can think of tripling or quadrupling that to make a really efficient home. And we'll show you some examples of that later. Thicker walls mean more efficiency if you thicken them by using more insulation. We also need to think in terms, if we're building a new structure, we need to think in terms of insulating those floors, not from the top, but from the bottom side. We need to think in terms of pouring that concrete, if we're using a concrete slab floor, on top of foam insulation board. And we'll show you some examples of that later. The insulation, we typically, I tell people, we typically build our homes inside out anymore. We like to put the masonry on the outside because it's pretty and it's strong, it's durable. But if we put masonry on the inside of that insulation, what happens is we dramatically increase the comfort level in that building, and we increase its energy efficiency. That doesn't mean you can't still have a veneer of stone or whatever on the outside as well for looks, but we need to think in terms of adding mass inside the house to spread out those temperature fluctuations over the day so that solar energy can be more efficient, as well as any kind of heating source that you use can be more efficient that way. South-facing windows can maximize your solar gain. If we minimize the windows on facing in other directions, we have less heat loss. Makes sense if you think about it. And higher efficiency windows are out there these days that can be triple pane. Some of them are filled with argon or krypton gas that helps prevent convection and reduces conduction of heat to the outdoors, so they're much more efficient. And then we've already mentioned thermal mass to a certain extent. Thermal mass can be masonry, whether it's brick, block, cement, or other, or it could be water in tanks or cisterns. I won't show you any examples of cistern types, but some people have used these to good effect in their buildings. They cover them and holds a lot of heat. But we have limited time today, so I'm not going to talk about every possible technique out there. Just expose you to some of the more prevalent ones. And then lastly, one technique that we can use to improve the energy efficiency of a building is earth berming. That is piling earth around the outside walls so that it also aids in smoothing out that fluctuation in temperature in the extremes of the year and over the course of a day as well. First, we'll talk about solar water heating, and the passive solar water heating will come first. Our first example here is of something called a batch water heater. And in this case, what you're seeing is a do-it-yourself homemade project, and it comprises a black painted tank. In this case, it looks like it's a gas-heated water heater tank that somebody scrounged from an old water heater, and they're piping water through it. They put it inside this insulated box and covered that box with plastic glazing or glass. This thing sits in the sun and absorbs heat, and it is its own collector. It's its own storage medium. There are no pumps. It's usually a do-it-yourself solution, but you can find some of these. You can find some of these out on the market if you look hard enough. The problem with these in Illinois is it's not really a good viable wintertime solution because we have days like today where it's freezing cold and snowing, and you don't want these tanks or the pipes servicing them to freeze up. If they do, they'll bust, and you'll end up having a leak that you'll have to deal with. So it's best to think of these in Illinois as a 3-season heater, and then if you use something like this, to be able to drain it for the winter time. It could be used as a cabin. I've seen lots of people use these for cabin water heaters, and that they only intend to use in the summer anyway. Then they drain them and they're done for the season. Very cheap solution, whether it's do-it-yourself or a purchase. There's something else called a thermal siphon water heater. In this case, it uses what we call a flat plate water collector, solar collector rather. And the flat plate collector uses copper tubing typically that's attached to maybe aluminum backplane that serves as an absorber. We paint all that black and we cover it over with glass or clear plastic to hold in more heat. And the water flows naturally through convection up into the tank as depicted in this diagram. Here, the cold water in the tank tends to flow out the bottom tube, and as it warms up in the solar collector, it is driven to rise higher and back into the tank again. Now again, this is a commercial solution that you can find out there. I've seen these in my travels around the world in other countries. They work well in tropical climates, maybe in Florida. They're not so great again in Illinois because you've got some water line potential freezing hazards here, as well as in the panel itself. So this would be something you'd have to drain again to have functionality for 3 seasons. Would make a great a cabin or vacation home solar heater. And in this case, if you had the solar panel sufficiently far away from the tank, you could conceivably have the tank inside the house or in a building and the solar panels outside, but you'd still have to drain no panel, even though you might not have to drain the tank. Still a good solution if you're looking for a vacation home or something. To get around those problems with freezing cold climate in Illinois, we use something that looks like this system, a little more complicated. This system uses a pump. It's an active system versus a passive system to pump glycol solution, an antifreeze solution, through the solar collector and back into the tank. The tank then has these coils to separate that antifreeze solution from your potable water. You don't want that antifreeze solution to mix with it and back out into the solar panel again. All of that is controlled by this electronic control unit. It's a differential pump control unit that detects the temperature of your solar panel and the temperature of your tank and determines when to turn the pump on and how fast it should run. Often these can be interfaced to your computer so you can see what's going on over the course of a day if you care to. In this case, we have an auxiliary heater attached to the tank, and it uses an electric heating element. This is another way of backing up that solar power because, of course, we don't get sun all the time. So we'll need an auxiliary heating unit for wintertime use especially, but anytime we have sun-free periods. That auxiliary heating unit doesn't have to be part of that same tank. It could be a separate conventional water heater like I have, which I'll show you towards the end of this presentation, so that the preheated water coming from the solar tank would flow into that conventional water heater where it would get topped off to the operating temperature you need for your home. An alternative to that conventional water heater could be a tankless water heater. In fact, I think that would be an ideal solution that would even save you more energy. So that's a typical kind of pumped solution these days. You can buy complete kits of these. They range to be $3,000, $4,000 for a complete kit, which sounds kind of pricey, but when you consider that they'll last you for decades with expert installation, maybe 30 or 40 years, that makes a decent investment in my view. Typically for a family of 2 folks, you might only need 1 solar panel depending on the size. For a family, say of 4 or 5 folks, 2 panels and an 80-gallon tank makes sense. Your mileage could vary, and your installer might consult with you to help figure out just what size system you need. So there are different kinds of solar collectors for these kinds of pumped solar water heaters. This is the flat panel collector that we've seen before, mounted on a roof. As you can see, there will be a need for the plumbing to go through the roof surface. A professional installer will use special equipment to make that happen, and flashing to ensure that it's a durable, leak-proof installation. You'll also see that there are some struts here that are used for racks that mount that to the roof surface. So that means there will also be some additional surface penetrations, roof penetrations, and those like this will have special flashing and other features to help make them leak-proof for decades to come. These flat plate collectors typically run about $500 a piece, give or take. And that in contrast to these evacuated tube collectors, which are more efficient, but about double the price. As I noted, these are more efficient because they have that vacuum inside the collector tubes. These tubes are basically glass tubes with a copper tube inside that's configured to collect the heat. Inside that copper tube, they might have a special, it's like a refrigerant that boils when it gets hot, so that the heat ends up going to the top into this unit and getting transferred in this, what we call a manifold, to the heating fluid, the solar fluid, the glycol antifreeze solution that goes down to your tank. Now, these are more fragile than the flat plate collectors. These can occasionally bust with a greater frequency, I hear, than these. And they occasionally lose their seal. You can see these caps on the end that might that might leak over time. These vacuum tubes are individually replaceable, but it takes climbing up on the roof to do that. And I don't know that they've been out there a good 10 years or so, so there should be some kind of track record. If you decide to go with this more efficient type of collector, you might want to look at the track record and the reliability records if they're available for that. I see we have a question. How many years payback? Well, that's highly variable depending on your installation. It's really hard to say. So is a plumbing license required to install? Yes, in addition to an Illinois. It depends on your municipality. Some of your municipalities may not really care if you're a do-it-yourselfer, you can get away with doing it yourself. I did it myself. I'll show you my project later in the presentation. But the quality of my installation may not be what you could get from a professional installer. I'll tell you that. And I went through a lot of reiterations, reinventing the wheel that I wouldn't have had to have done if I had hired somebody to do it. I had a lot of hassles, frankly. So I don't know how to answer the first question on how many year payback. I really don't know. It's you have to think of it long terms. Some people have seen paybacks on the order of 10 years for a system that lasts 30 years. Another component of your pump solar system are all those pumps and valves and electronic controllers that I mentioned earlier, as well as gauges. It's really a pretty complex system that was not necessarily well illustrated by those cartoons I showed you earlier. Much of that equipment today can be integrated into what we call an integrated solar thermal pump station. These things have much of your mechanical equipment inside one convenient package that makes it easier for your installer to install, so there are lower labor costs involved. If you're a do-it-yourselfer like me, I should have done this from the get-go. I found out it was a tremendous amount of work plumbing all the copper and the components together, all the soldering and everything, and ended up wishing that I had, in fact, spent a little bit more money and got one of these. These might run $1,000, $1,200 depending on the company. These are insulated on the outside, and for this model over here has a metal case with insulation on the inside, but principally the same thing. You'll see the need for an expansion tank that takes care of the expansion of the fluids and any air that might be in the system so that your system doesn't bust. Not an auxiliary water tank, by the way. Here's an example of a pumped system like that we just saw on a roof of a college building in Northeast Illinois University. I don't know what town that is in. Maybe Nicola does. No, okay. At any rate, there are 5 collectors in this system, 5 flat plate collectors. They're about 4 feet by 10 feet, according to the website that I pulled this from. And that system produces about 250 gallons of hot water a day. So that's for a large consumption installation. That's not the size most households would need, I would think. As I mentioned earlier, one of these might be fine for a couple, max 2 for a family of 4 or 5. This feeds into a 120-gallon tank. And I don't have any statistics on how much that costs or how much it saves for them. And NEIU is in Chicago. Thank you, Bob. I think that's Bob. Next, we're going to move on to space heating. We'll start out with passive space heating. Passive solar space heating relies on the creative use of solar windows as well as overhangs to regulate the amount of sunlight you're getting into your home. The overhangs are designed so that you get less sun in the summer. You'll see an example in my own installation later about how this works from my solar hot water installation. But that overhang allows plenty of wintertime sun to get in through that window and provide heating to your space. The windows here need to be large and they need to be highly efficient so that you don't lose more heat than you gain. Also, you might think in terms of using lots of thermal drapes or shades to help make those windows more efficient in shady weather or at nighttime. We talked about thermal mass indoors earlier. This is an example of how the solar mass can be used either as walls on the inside or as a concrete slab you might find on the floor in many homes today. Unfortunately, most homes that are built out there do not have the thick insulation underneath that is needed to make them more efficient. So I recommend strongly, if you're thinking about building a new house these days and you expect to use a concrete slab, please, please, please think in terms of having the builder use the styrofoam insulation thick underneath that slab. So I think that covers it. That's a very simple use case scenario. The problem with these kind of homes is that you can't get that sunlight into the back of the house. If you have the house divided into rooms, then that presents a problem. So you might need some kind of ventilation to help move that air around, move the heat around. Or you could have clerestories or maybe some dormers that solve that problem for you, depending on the design. We talked about that. Here are some examples of passive solar homes. They are not designed to get 100% of their energy from the sun, their heating energy from the sun. Instead, as according to this website, you can get 25% without adding costs by designing around a good passive solar index, whatever that means. I'm not quite sure what that means. I'll have to make sure I understand that the next time, Nicola. I shouldn't grab a quote without fully understanding it. These are pretty modern looking homes. As you can see, they've maximized the amount of south-facing windows. In this one, they have very few on the sides, and they're kind of boxy looking, modern looking. They don't have to look that way. They can look more traditional or more rustic, depending on how the architect designs them. Here's one that looks a little more rustic. And again, you can see the reduced number of windows on the west side in this case. This space, by the way, to make a great place to put some photovoltaic solar electric panels or your pumped solar hot water panels. We'll talk a little bit about Trombe walls. Trombe walls are a concept that's been out there for decades. I first heard about it back in the 70s or 80s, and that relies on a thick thermal mass here in the solar window itself to absorb the sun. These have been used a lot out in places like New Mexico and Colorado, where the weather's a little less severe, maybe in the wintertime. But I've seen them used elsewhere as well. And again, they take advantage of the overhangs to regulate the sun in the summertime and versus the wintertime. This cartoon's a little bit oversimplified. Most Trombe walls I have seen have some kind of vent, like this one illustrates here, to allow air to circulate. It's not simply a matter of conducting the heat through that thick concrete slab or masonry slab and getting it into the living space. Now, this can be augmented by dampers and fans if need be, maybe even some attic fans to help move the sun around or move the heat around, excuse me. And then you can see variations on a theme by using sun spaces or greenhouses attached like this as well. Some folks have used water tanks in place of the masonry for these Trombe walls and have made that work for them. I've seen people use huge aquariums essentially for this function. Down here in the lower left, you can see an example of a Trombe wall in action. Actually, there's no action because it's completely passive, right? Here on the left, you can see the outer window along with the inner window, and then the dark Trombe wall. It's painted dark on the outside, but it's actually a lighter color on the inside, a little more pleasant to look at when you're inside. And you can see they have some vents here to allow circulation as well as a little bit of lighting into the space. You can find out a little bit more about the, whoops, there. I keep covering up my, I can't read it to you because it gets covered up. There we go. The Green Passive Solar Magazine is an online magazine out there. You can read a little bit more about these kind of techniques. That's where I got this example from. So passive solar homes don't have to be new built construction. You can modify some existing construction to do it. The one on the right here in this picture is an example of that. But beyond that is actually an example of something called passive house. Passive house is something that was popularized in Europe and has migrated to us over the past decade or so. Passive house is a design concept for ultra efficient houses that take advantage of very thick insulation, thermal mass and solar energy to get up to a 90% reduction in your heating and cooling needs. And it doesn't have to be just houses. It could apply to any building, really. This is a row house in Chicago that was remodeled to passive house standards. I don't have the statistics on it for you today, but you can learn more about it at kenwoodpassivehouse.com online. Now, the passive house technique is accomplished by certified passive house builders. These are folks who, like people in the solar industry or electrical industry or the architecture industry, get specialized training on how to build and how to design these kinds of structures to be ultra energy efficient. You can find out more about that at Passive House Institute, phius.org. And they also have a Find a Professional page if you're interested in upgrading your existing home or having someone design a new home to passive house standards. You can go on their website here and find a certified professional. If I were to build a new house today, I would probably go more along this lines. Here's an example of a passive house built to those standards called the Smith Passive House. It's located in Urbana. I tried to find more examples of these in Illinois. I only found a few before time to put this presentation together, but this is a good example. It's not a small house. It's about 1,450 square feet. Looks like it's 2 stories. And you'll see it's insulated on all 4 sides about R56. That's about 4 times the normal code requirement of R15 or 16. So that's a lot of insulation. Thick walls, they get there by using 12-inch thick trusses, and then they add 2 inches of additional foam board on the exterior before they slap on the, it looks like clapboard or some kind of siding there. They also have a concrete slab floor, but that is over 14 inches of foam insulation, rigid foam insulation board. That's a lot of insulation of the floor. And naturally, they're using high efficiency windows. Now, the website says that their winter bills, and they use electric resistance heating. They don't have a heat pump. They don't have a gas heating. They use electric resistance heating, which is pretty pricey to use. It only drives their heating bills up in the wintertime about $35. That's pretty affordable. And then they use earth tubes for cooling. That means they use a long, maybe an 8 or 10-inch diameter tube, several of them actually, going through the ground in the yard and venting out into the air at some point, maybe 50 or 100 feet out. And they use fans or maybe natural convection to pull cool air through the ground and back into the house in the wintertime. So this is an example of the art of the possible. This particular house is kind of boxy, and passive house, or any real energy efficient house, to make it as efficient as possible, it tends to drive it towards a boxy structure to minimize the square footage of this exterior surfaces, and that makes it more efficient. But you don't have to do that if you want to make some engineering compromises. So moving on from passive house, what we'd like to talk about next is pairing solar thermal energy with radiant heating. It turns out that radiant heating, that is using pumping the fluid through, say, a slab floor like we see here, or through radiators, we'll show you in a minute, works very well with solar thermal because you can take advantage of the lower temperatures. Solar thermal produces, in general, lower temperatures than something like a boiler that you would ordinarily use to heat something like this with. But it's a better way to take advantage of those lower temperatures because with a warm floor, you don't have to push air around. It is a more uniform, even heat. When the heat is in the floor, it feels more comfortable. When you have forced air like I do here, I have a heat pump. Even though that temperature is higher, it's like 130 degrees maybe coming out of the heat pump. It feels chilly when it's blowing on you because your skin is moist and it's forcing that moisture to evaporate, and that evaporation makes you feel chilly even though it's warm air. So in a gas heated home, the temperature of that air coming out of the furnace tends to be hotter than that. It's more like 150, 160 degrees to make you feel comfortable. But in a heat pump, I'm kind of being long-winded here. All in the long way of saying that heating your floor is both more efficient, and it's a great coupling of solar thermal, because solar thermal is a low temperature process that is hard to adapt to forced air. When you try to use it for forced air, you get conversion inefficiencies, and then you feel cold because you've got air moving around. So this is a better way to use it. Long way of saying that. So these kind of techniques use something called PEX, basically plastic tubing, special plastic tubing embedded in the floor. Here you see the styrofoam insulation. Hopefully that's rather thick. I can't tell how thick here. And then they've got some mesh they're using to tie that PEX to keep it in place, and they're going to run their glycol solution through that. Now, a typical installation for a building this size, you're going to have several what we call loops of PEX or circuits, so that they're separately operated. They have separate valves or pumps that are operating those to maintain different temperatures in different rooms. So that adds to complexity of the system. We'll show you a little bit about that in a bit. Now, this isn't just for new construction. I think this is an ideal way, by the way, to do new construction. Either this or passive house construction is the way to go. You can adapt this technique for retrofits. This is going into the second story of a house, it looks like. Excuse me. In this case, they've got some specially manufactured flooring that they've put down that has grooves. Those grooves accommodate that PEX, and these aluminum or steel fins that help radiate the heat. This helps spread the heat out. Now they'll come along and they can put on, say, a floating tile, a rubberized insulation over this, and then put a floating tile or floorboards over that. And it works pretty well. I did not end up doing this in my own house. I wanted to do this because it can be very invasive. You got to remove your molding. If you've got cabinets, if you got plumbing and stuff, you got to take all that into account. So I decided to go the opposite direction. I'll talk to you about that in a bit. This is another way you can use what we call hydronic heat from solar thermal. The old baseboard heaters you might have seen around can be reused for solar energy. These are more modern heaters that are lighter weight. They're not made of cast iron like the old style ones, but they're lighter weight, so they can make use of lower temperature heat coming from the solar collectors. It just means you need about twice as many of them in your room as you would the old cast iron things. And then another alternative is a panel heater. And same story here. They're lighter weight so that they respond more quickly to the lower grade temperatures for your solar energy. I went with baseboard heaters in my own home, and I'll show you those in a bit. So this is one of those loop controls that would be required for those hydronic heating solutions. In this case, it's a 4-loop hydronic manifold for 4 of those PEX loops. These are the valves, electronically controlled valves for those zones. They are controlled by an electronic box here that senses the temperatures, the thermostats. And then each of these, let's see, there's a hot water inlet and of course a cold water outlet. That's going back to your solar project, solar thermal project. So this would be for a 4-zone system, a rather small system. If you've got a big house with, say, 8 or 10 rooms, you're going to need something more complex than this. This is an off-the-shelf component, so one of those integrated components that you can buy to save labor. I ended up building my own, and it was a pain, believe me. It's probably best to just buy this. If you're one of those do-it-yourselfers, buy this ready-made and just hook it up. We can combine these different kinds of systems. The hybrid, what I call a hybrid solar thermal system here for this house. We've got passive components. We've got active components. We've got pumped water. We've got the indirect solar through the windows. And you can do that. That can be very helpful for a larger house where you might have difficulty getting the sun back into the back part of the house or into other rooms. Maybe you've got a second story or a clerestory. You can use the hydronic technique to get that solar heat back there. Here we show an insulated window box that helps bring down or helps improve our efficiency for that window. And you notice that, again, that thick insulation under the slab and in the walls and in the roof. Some more questions here. Do those valves modulate or are they binary? They're binary. They're either on or off. Yeah, good question. At what point do higher R values hit diminishing returns? Yeah, it's a great question. I can't answer that. I'm not an expert on those design techniques. And again, this is an introduction to ideas and concepts that I hope get you excited about these, the possibility of using solar thermal. You would have to consult with a professional, really, like a passive house designer, to get an answer for that question. Good question, though. Now, the cheapest solution of all for getting solar heat into your home is one of these solar air heaters. This is what I built when I first got into solar way back in my college days in the late 70s, early 80s. We had something called the energy crisis, and it got me thinking about there's got to be a better way. And I built a couple of these for my parents' house and heated the kitchen for brief periods while the sun was shining. And there was one day, 1 week, I remember, when it got so warm in the wintertime, we had to disconnect it. We were sweating inside. It works. It's a cheap solution because these are just basically boxes that you can mount on your wall or on your roof. And they can be passive solutions without fans that convect naturally, bringing heat indoors, or you can use fans to boost them. You might want some dampers or something to help prevent backwards cooling at night when the sun's not shining. That can be a problem. A very cheap solution. You can buy these commercially or you can build these yourself. There's lots of plans out there to do it. There's a disadvantage in that there's no storage, but it's so cheap. That's maybe not a concern for you. And then there are no tax incentives either, like there are for other techniques. I'd be remiss if I didn't mention pool and spa heaters. They're very cheap. You can buy plastic versions of these things. They're basically plastic sheets with plastic tubing attached that you can throw on a surface, whether it's your yard or roof, maybe an outbuilding, and pump the water through it and back into your pond. No need for heat exchangers. These are really 3-season use things too. They're not going to give you enough heat to swim in the wintertime. You could try using flat plate collectors or those vacuum tube collectors, but that can be a pricey solution. You might get some results, especially if you have an indoor pool. Now, I mentioned solar incentives. There are no state incentives, unfortunately, for solar thermal like there are for solar electric. The Illinois law, however, prohibits solar equipment from being assessed as part of your property tax value. So that's a good thing. I don't know how you distinguish between, if you got a passive solar house, how you distinguish that, but maybe that's not really a concern. It's more of a concern if you have those external solar panels and all the pumps and things that go with it. It's really the passive solutions that are tax exempt here, rather than the passive solutions, I suspect. There's also something called the solar homeowners right that stipulates that homeowners associations cannot ban you outright from having solar energy devices on your property. They might make it more difficult for you to do it by placing stipulations. They do still retain the right to do that. We always recommend it's best if you have an HOA to work with them to make sure you understand what their requirements are before making enemies of them. Your neighbors too, for that matter. There are some federal incentives that apply. There's a tax credit that amounts to 26% for the next couple of years. So that's a great thing. It goes down to 0 in 2024, by the way. But it still retains a 10% discount for commercial and utility scale. So that applies to solar thermal as well as to solar electric. Now, if you decide to hire a professional to do solar heating equipment for you, it's always best to look for proof that they have certification from NABCEP. NABCEP, that is the North American Board of Certified Energy Practitioners. This is like the plumbers and the electricians have out there, a standardized way of making sure that their folks in their career field have the right training and get recertified every few years to stay up to date with code requirements and the state of the technology. They do have that periodic recertification. It's also a way for the industry to hold installers accountable for their ethics. If you have a problem, you can register that problem with the NABCEP folks and hopefully get some resolution on that. Very important. So we're at the part of the presentation where we typically delve into the presenter's story. So this is my story for the next 5 minutes or so. Adventures in do-it-yourself energy is what I've called it over the years. My wife and I have done quite a bit of this between the electric power on the roof, which we're not really going to talk about today, and the solar thermal here. It's been quite the set of adventures. Here what you see is the 6 solar panels I designed, built, and installed on the side of my garage. I used some off-the-shelf components to do this. I bought solar thermal absorbers from a firm I don't even know if it exists anymore in California. They're basically copper tubing arrays that are mounted to solar fins and mounted on a manifold that distributes the water between the individual tubes and fins. And then I mounted all those in a framework that I built from wood with insulation backing and an aluminum frame, and covered it all over with a fiberglass, clear fiberglass glazing. So these are about 8 feet tall and 3 feet wide each. And you can see, we mentioned overhangs in the previous parts of the discussion. You can see the shading here. This is probably a May timeframe, April or May timeframe. We're still getting a good amount of solar energy striking the panel, so I'm getting all the hot water I really need for my home, and then a little bit of heating that I use in the basement, even though I have that overhang. And then in the summertime, that shadow comes all the way down to almost the concrete, within a foot of it, and that keeps these from overheating. In the wintertime, when the sun is low, there's only about a foot or so of shading there, and so I still get plenty of heat in the wintertime. The water pumping equipment, the pumping station I built is in the basement. I've set the tank and the collector for about a maximum of 110 degrees right now. I can change that, but I've set it at that for now so that I get a little bit of heat out of my radiators in the basement. I also have geothermal heating and cooling for the house, and that system, when it finishes cycling during a heating or a cooling cycle, it dumps excess heat into the water tank, the same water tank I use to dump my solar thermal in. So when people ask me, well, how much do you save with solar? I say, well, I don't really know, because both of these processes are dumping into the same solution and reducing my energy use at the same time. How much of it is solar? I don't know. How much of it is geothermal? I really don't know. But overall, the combination has reduced our propane use by 80%. We used to heat with propane. We used to heat all of our hot water with propane. Now we mostly heat with these and use a little bit of propane for our clothes dryer. And this is our 80-gallon water tank in the basement. I've wrapped it with insulation. These pink foam covered pipes coming in here go into the coil inside this tank in the bottom. That's how my solar glycol solution, antifreeze solution, gets in the tank, into that coil inside the tank, that is, and heats the water. There's a separate inlet for the geothermal. Then you can see my conventional propane water heater over here, 40-gallon. This tank with the solar preheated water and geothermal preheated water feeds into that tank to be topped off, maybe another 10 degrees. I'm eventually going to replace this conventional water heater with a tankless water heater to save even more on my propane bills. So we've gone from basically $900 to $1,000 a year in propane expenses between the geothermal and the solar thermal, so that now we only pay about $200 a year. I'd like to reduce that further. Here's an example of the hydronic baseboards that I use for the excess heat that I don't need for heating water. I just dump it into my basement and make it a little more comfortable. I got one within arm's reach where I sit now, and it helps make it a little bit more comfortable on a sunny day. So I've got more questions coming in. Sorry, I've not been paying attention to them. We'll try to catch up on them. Would a trombo wall that has plumbing coils in it work as both solar water heating and heating for a passive system? You might be able to make that work. There would be some design involved. I couldn't begin to tell you how to do that. I'm not an expert. But some engineer out there might be able to help you understand how to do that. Does the glycol solution have any barrier to your water in a tank? Oh yeah, like I showed on the previous drawing when we were talking about it in the solar thermal presentation. Let's go back a ways. That water goes through, or that glycol goes through a coil inside the tank. It's a stainless steel coil you see here that completely separates the glycol from the potable water. There's no way it can interact. In my situation, I have a stainless steel tank with stainless steel coils. I spent extra money to get something I felt was going to be very long lasting, so I got stainless steel. You can buy fiberglass tanks, but in all situations you must have separation. According to code, you must have separation. You don't want that glycol mixing with your water, and you wouldn't want it anyway because it tastes nasty and might make you sick. So if I missed any other questions, some of these are more like comments than questions. Nicola. Someone was talking about building a super insulated passive solar home in 1989. Works great when they have sunnier days, and we've had most of this winter. And in PV, great. That's Bob, I think. Yeah, great. Thanks, Bob.
And I just wanted to mention, somebody asked if the links will be provided to us in a follow-up email. And yes, they will, along with a recording of this presentation.
Yeah, good question. You know, I meant to prepare a handout that had the links, and I neglected to do that. But yeah, they will be available in the video, certainly.
Yes. I do see a new question. Do you take the excess heated water from your geothermal and run it through a radiator? Does that shortchange your water heater use?
Right. So yeah, any excess, I do have it programmed so that the solar water tank heats up for about an hour before I kick on my radiators. I want to get a head start on heating the water so that it doesn't cool the water coming out of the solar so much that it won't heat beyond, say, 90 degrees. I'd rather the tank get up to 110 degrees if I can, or get up close to it, and then have the heat begin flowing to the radiators. So that's the way I do it. I have it programmed to run just to the tank for an hour, and then the radiators kick in and help dump any excess heat there. That would shortchange my hot water if I kicked in too early. And that's a great question. In your slide about baseboard and panel heaters, there was a statement at the bottom about those methods not pairing well with solar heat. Could you explain? Oh, so I think that, let me go back to that slide. It's the old cast iron steam radiators that don't work well with solar heat because it takes so long for them to build up their own temperatures. They have a lot of thermal mass there. At least this is what was explained to me by someone who's a professional in the industry. These lighter weight radiators and panel heaters are better for lower temperature heat to make sure you get that heat into your environment quickly, unless you really are looking for that solar mass or that thermal mass to be consumed in a radiator. We typically think of those as taking up a lot of space in our rooms, and these are more petite. They take up less space. Hopefully that answered your question. It's a combination of the fact that they're massive, they're bulky, and they take up space, and then it slows down the ability to get space into your, or heat into your space when you need it. So I'll go ahead and move on to the next slide here. If there are other questions, we can come back around to them. So the next couple slides we have are addressing ISEA. ISEA has a Find a Professional tool on their webpage. They do have some solar thermal installers who have a presence there that you can find. It'll take a little bit of digging because the way this Find a Professional website's set up now, it does not specifically identify and distinguish solar thermal from solar electric installers. So you have to do a little homework in that regard. You'll also find that there probably will be some contractors in your area who are not part of the ISEA who can do this work for you and are certified. Our Find the Professional tool only applies for ISEA members. We do recommend you contact multiple professionals and see who gives you the better bid and who you trust more in terms of installing a system. Make sure you get references or some idea of what kind of projects they've worked on in the past, that they have some kind of track record, in other words, a good track record. Now, ISEA is always looking for members. We're a membership-based organization that helps us keep running membership dues and the fundraisers we do. And we help to make sure that we keep solar moving along in the state of Illinois. As a member, you can get discounts to ISEA events and classes, and you can get updates concerning the state of law and policy in Illinois, which we're keenly interested in as members. And you get to vote for their ISEA board members. We are a public education organization. You can go to our website and learn much more about solar energy, whether it's solar electric or solar thermal or what have you. And there are other aspects we're working on where we have electric vehicle presentations that are being built and some others that Nicola can go into more detail about.
I do want to briefly mention a few upcoming events. We're continuing this series on related technologies to solar. Next month, February 24th, I think. Yeah, Wednesday, February 24th. It's not up on the calendar yet, but it will be very soon. We will be having a talk about electric vehicles and how electric vehicles can be integrated with solar. And also related to electric vehicles, another great way to support ISEA and the educational work we do is to enter our annual Tesla raffle. I'm putting a link to the Tesla raffle in the chat box if you're interested. All that money goes directly to maintaining our resources on the website and helping to fund these webinars and a bunch of other educational initiatives. And it would give you the chance to win an awesome car, the Tesla Model X. And so that is a few things that we have going on. We will also be continuing our regular Powering Your Home with the Sun webinars, which is explaining more about solar electric PV panels. And there will be one in February that's not quite up on the calendar yet, and we've got one coming up on March 8th. So be on the lookout for some more information about those. And I don't see any other questions, but now is sort of your last call if you've got them. Type them into the chat box. And thank you so much for joining us today. And thank you, Kevin, for an excellent presentation. Oh, I do see a new question, a couple new questions from Tom. He asked, what happens when your solar wall is wicked hot in the summer?
What happens when my solar wall is wicked hot in the summer? Yeah, I don't really have the problem anymore. I did for a while, and I got my water tank got hotter than I was comfortable with. So I covered the collector over with a tarp to keep the sun off it. That helped a little bit until I came up with this method to dump heat into the basement. The basement's always cold, even in the summertime. It's in the 60s down here, so I just dump it down here. And that might be sort of counterproductive to the air conditioning, but that's what I'm doing.
Also, a quick clarification, Bob wanted to know when the EV event will be. That webinar will be February 24th. It's not quite on the calendar yet. We're still putting together a description, but it will be very soon, and look out on our social media and in your email inbox for an announcement and a sign-up link.
I see that Joe Howell answered the question on cast iron radiators as well there. So whoever had that question earlier, it looked like he kind of backed up what I had to say, but that they also distribute heat longer once they do get hot. So yeah, they kind of work like thermal mass. Good with modern high efficiency boilers. And then Tom expands on that a little bit further about the need for steam radiators to work with steam as they need higher energy content. And then the last question there on the glycol again. In the past, I thought a heat exchanger was required to prevent accidental contamination. Yeah, I'm sorry, Michael, that's exactly what I'm using. It's a heat exchanger. It's a coil inside the water heater. I didn't use the term heat exchanger, but that's exactly what it is. That prevents that solution from mixing. Great clarification, thank you.
Okay, I think that might be about it for today. So thanks again for joining us, and thank you, Kevin. And we hope to see you at our future webinars. Thanks so much.
Thanks all.